Welcome back. This is activity 3.3 in Toss the Cup. We are comparing probabilities using proportional reasoning. Let's get started. If you know the probability of an event, then you can use proportional reasoning to predict the number of times that an event will occur through an experiment. Now, that word proportional reasoning is important to understand because it's the whole topic of this activity. And if you don't understand what it is, then you're not going to understand what it is that you're doing with the math. All right, so I'm going to give you a quick example. So, say that I'm selling lemonade at a lemonade stand and I make $10 in one day. Well, I can use proportional reasoning to estimate the number or the amount of money I will make in 3 days. Well, if I make 10 in one day, then I can scale up by three to predict that I'm probably going to make about $30 in 3 days. And then this also can be set up as a proportion. So $10 to one day or 10 over 1 would be equal to $30 to 3 days or 30 over 3. You do not have to copy this down, but that is just a quick example, a real world example to explain what proportional reasoning is. So that's what we're going to be doing in this activity today. Alrighty, what I want you to do now is take a look at this worked example, and I want you to take about 3 minutes on your own and with a partner to annotate and read this to understand how to use proportional reasoning with probability. So take 3 minutes to annotate and read this. 3 minutes on the clock. Pause here. Alrighty, let's go ahead and I want to explain a couple things before we move forward. So, as you noticed in the worked example, they started with the proportion 7 over 20 and then used that to predict how many times the spinner would land on the sun if they spun a total of 60 times. And if you did not notice how they solved, I'll point it out for you. What they used here was cross multiplication. In my previous example, I scaled up, but this is also a method to solving a proportion by cross multiplying and then solving for x. Alrighty, let's move on to our practice. So number one says, suppose there are probabilities for the symbols on the spinner, or these are the probabilities, for the symbols on the spinner. So we've got the smiley. The probability of the smiley is 7 out of 20. The probability of the sun is 2/5. And the probability of selecting the star is 1/4. Now, I'm going to work through how you would find the probability of, let me just go ahead and read A. Part A says, if you spin the spinner 40 times, predict the number of times the spinner would land on each symbol. And part B says, if you spin the spinner 100 times, predict the number of times you would land on each symbol. So what I'm going to do is I'm going to give you an example or walk through an example of how you would solve this using the smiley as an example. And then I'm going to give you some time using those examples to solve for the sun and the star. All right, let's get started. So looking at the smiley, I'm going to solve part A first. So I want to know and predict what would it be if we spun it 40 times. So my original proportion, my original ratio is 7 over 20. And I know that is going to be equal to something over 40 because 40 would represent the total amount of times the spinner was spun. Here it's pretty easy to scale up looking at these numbers. I'm going to use a different color to show you. But I see that 20 and 40 are very easy numbers to work with. So I know that to get to 40, I can simply multiply 20 times 2. And what I do to the bottom, I must do to the top. Exactly. So 7 times 2 as well. That gives us 14. So I know that x would be equal to 14 for our smiley. Now, part B. If you spin the spinner 100 times, let's make that prediction. So starting with my original ratio, 7 over 20, or my original probability, 7 over 20, I want to know if it was spun a total of 100 times, what would that probability be? And again, I'm going to use a different color to show you. 20 into 100, that's another easy number to work with. So 20 to get to 100, I know that I can multiply that 5 times. And what I do to the bottom, I must do to the top. So times 5, 7 times 5, that gives me x is equal to 35, about 35 times. Alrighty, now that you've got two examples of how to use proportional reasoning to predict an amount, a probability, I want you to go ahead and find the probability for the sun using this original, oops, not the sun, hold on. Using this original probability, 2/5, that's our sun. And then I also want you to go ahead and predict the probability of it landing on the star 40 and 100 times using that original probability of 1/4. Set your timer for 3 minutes max. 3 minutes to do these four proportions, either on your own or with a partner. So 3 minutes max. Pause here. Alrighty, now that you've had time to work, let's compare answers. So looking at the sun first, when we spun the spinner 40 times, or if the spinner was spun 40 times, then we can predict that it'll land on the sun 16 times. We scaled up by 8. 5 times 8 gave you 40. So what we do at the bottom, we must do to the top. 8 times 2 is 16. And if we spun it 100 times, well, 5 to get to 100, we can multiply that by 20. 5 times 20 gives you 100. 2 times 20 gives you 40. Then for our star, if the spinner was spun 40 times, well, 4 to get to 40, we can multiply that by 10. 1 times 10 gives you 10. And then out of 100, 4 times 25 gives you 100. So 1 times 25 gives you 25. If you need to take a second, go ahead and get these answers down. But 3 minutes should have been plenty of time to get this down on your own. All right, moving on. So now let's look at C. It says, how did you predict the number of times the spinner would land on each symbol for the given number of times the spinner would be spun? Well, you used what? We used a proportion, but to be even more specific, we used proportional reasoning. Uh-oh, typo. Those aren't it either. Hold on. Proportional. There we go. We use proportional reasoning. Part D says, do you think you would land on the symbol exactly the number of times you calculated in parts A and B if you spin the spinner? Why or why not? Well, let's be real. Do we think it'll actually take the smiley for an example? If we spun it 40 times, do we actually think it'll land on the smiley exactly 14 times? Probably not, because we learned in the last activity about experimental probability, right? What actually happens isn't always going to be according to our prediction. So I simply wrote, and you can word this in other words, I simply wrote no, because nothing is certain with experimental probability. So go ahead and take a couple of seconds, write those two answers in your own words, and we are moving on. Alrighty, next page. It says, to compare the theoretical and experimental probabilities. I want to pause here before I continue reading. Really quickly, go ahead and remind your neighbor what is theoretical probability and what is experimental probability. One of the key learnings in this activity, in this lesson, is to know the main difference. So take a quick pause. Don't actually pause the video, but take a quick pause, think about it, and tell your neighbor or yourself what is theoretical And what is experimental probability? Alrighty, let's review. So remember, theoretical, you should have said, is what we predict is going to happen. And then experimental is what actually happens when we do the actual experiment. All right, let's continue. To compare the theoretical and experimental probabilities, you can use a measure called percent error. In probability, the percent error describes how far off the experimental probability is from the theoretical probability as a percent ratio. So go ahead and highlight, underline, or circle that vocabulary word, percent error. And what does it do? It describes how far off the experimental probability is from the theoretical as a percent ratio or as a percent. So on this page, we're not going to be solving for the percent error. Well, I take that back. We're going to get a little practice. But the first thing I want us to look at is the worked example to see an example of how it's done. So take about 3 minutes max, to annotate this worked example and talk about it with your partner or Casper. All right, 3 minutes on the clock. Pause here. Alrighty, now that we've had time to read and annotate, let's go ahead and summarize what we just read. And the great thing about doing this digitally is I can easily color code this for you. So notice I've highlighted all of the theoretical probability. So what I thought would happen was 7 out of 20 in yellow. And then in green, I highlighted all of the experimental probability. So it says, suppose you spun 20 times out of, or you 50 trials, okay? You spun 20 out of 50, and the experimental probability was 2/5. So using the percent error formula, which is, and I boxed it in that black box, it is the probability experimental, that's what that small e represents, the probability that's experimental minus the probability that's theoretical. So you're finding the difference between those two, divided by the probability theoretical times 100. So you're subtracting what you actually spun, take away what you thought you would spend to find the difference, divided by, again, what you thought you were going to spend to find that decimal error, and then we multiplied it by 100. Take a second to think, why did we multiply by 100? Hint, hint, it's kind of in the name, percent error. If you thought it's so that we can turn our number into a percentage, you're absolutely correct. So notice when they actually plugged in their numbers, they plugged in 2/5, which is their experimental probability, minus 7/20 divided by 7/20 times 100. Then that 2/5 turns to 8/20. Why is that? Well, because in order to subtract fractions, I need to have the same denominator. So they went ahead and changed that 8/20, that 2/5 to 8/20. So remember, we kind of scaled up here. 5 to get to 20, we multiplied by 4, right? So what I do at the bottom, I must do to the top. So 2 times 4 gave you 8, and that's how they got that 8/20. Alrighty, I went ahead and wrote that note for you just in case you needed a reminder of how they got that. And then they divided by 7/20. When they subtracted, they got 1/20. They divided by 7/20 and then multiplied by 100 to get about 14.3%. And so 14.3% is, and listen carefully because you're going to need this information when you answer the following questions. 14.3% is the percentage of how far off the experimental probability was from the theoretical. It's right in the definition. So that's exactly what that 14% represents, how far their estimation was or their guess was. So now that we've understand what percent error is, it's time for you to answer some questions. So you're going to answer 2, 3, and 4, and then we'll come back and do 5 together. So question 2 says, write a sentence to interpret the result in the worked example. Number 3, what would it mean to have a 0% error? What do you think? Use an example with the formula to explain your reasoning. Number 4 says, what would it mean to have a negative percent error? Use an example to explain your reasoning. And number 5, we will get to afterwards. So you are completing questions 2, 3, and 4, thinking about those by looking at the worked example, questions 2, 3, and 4. Alrighty, go ahead and set a timer for about 2 minutes to answer those 3 questions and pause here. Alrighty, now that you've taken 2 minutes to answer those questions, let's compare answers. So question 2 says, write a sentence to interpret the results in the worked example. So I explained this before I paused, but the worked example shows that the experimental probability was off by 14.3% or 14.3%. Question number 3, what would it mean to have a 0% error? Well, if you've got 0% error, that would mean that there is no difference between the experimental and the theoretical probability. They would be the same. And then for number 4, it says, what would it mean if it were negative, a negative percent error? Well, a negative number would mean the experimental probability was less than the theoretical. So notice how in the worked example, and I'll highlight using purple, why not? In the worked example, notice 8/20 is larger than 7/20, okay? So then when we subtracted, we got a positive number. But if our experimental probability, meaning if what actually happened was less than our theoretical, then that would give us a negative number, resulting in a negative percent error. Alrighty, now that we've got that understood, let's look at number 5. It says, use the spinner results from the previous activity to calculate the percent errors for the sun and the probability of it landing on the star and describe their meaning. Now, for time purposes, we're only going to do one. I'm going to help you get it set up. You're going to attempt to solve it, and then we're going to check our answers at the end. So for this demonstration, I went back to the previous activity and we're going to use the sun. This was the experimental probability when we used that spinner, and we got 12 out of 50. So 12/50 was our experimental. Then we're subtracting our theoretical, and our theoretical we're getting from the previous page. For the sun, that was 2/5. So I'm going to use orange to show that. 2/5, and then divided by our theoretical, which was 2/5, times 100 to turn it into a percentage. Alrighty, I'm going to give you some time to go ahead and solve this. Remember, you must have the same denominator to subtract, and then divide, and then multiply by that 100. Take about 2 minutes. See if you can solve this on your own, 2 to 3 minutes, and then we'll go over the answer. Pause here. So here is my work. The percent error that we got, or that I got, was negative 40%, meaning my experimental probability, or what actually happened, was 40% less than what we thought would happen, or we were 40% off of our theoretical. Also notice I drew an arrow to my work. So I started with 12/20, taking away 20/50. or 12/50ths, excuse me, 12/50ths minus 20 over 50. I scaled up and just turned my 2/5 with a denominator to have a denominator of 50. That was easier for me to interpret. And then I subtracted, I got -8 over 50. And then I turned that division uh, just to look a different way so that I didn't have a fraction over a fraction because those lines can get confusing. And so I just wrote it out as a regular division problem. And then from there, I solved in the green. However, you can also divide by going straight across the top and bottom. So 50 divided by 50 gave you 1, and that would be -8 divided by 20 over 1, which gives you the same exact answer, which gives you -0 and 4/10. And then you multiply that by 100 and you get 40%. Also, if you turned 8/20ths into a fraction and then made it a decimal, then you would have gotten 2/5. Multiply that by 100, and then you still get the same thing of 40%. But this is a -40%. Alrighty, that was a lot of math to end this activity, but awesome job. You now know and understand what percent error is, and you also know how to proportionally reason. This concludes the learning for this activity. I will see you in the next video.